Good evening, everyone. We'll start today's session shortly till some more participants join in. You can quickly confirm if I'm audible. You can type a yes in the chat box. We have for confirming. Just couple more minutes. We'll start today's session. Hello, everyone, and welcome to our webinar, Deep Learning Unlocked, Powering the Future of AI. Thank you for joining us today. And this exclusive session is designed to, help you gain a deeper understanding of deep learning, which is one of the most transformative areas of AI. So during this webinar, right, we will explore the foundational principles of this deep learning and, how neural networks work, also the evolution of neural architectures and their impact on today's intelligent systems. Also, the key applications of deep learning will be covered across industries, along with its advantages and limitations. Once again, we are excited to have you all with us for this insightful session. And our speaker for today is Mr. Shyam Venkatesh, who serves as the Director of Architecture at fintech industry with over 20 years of experience in this industry. Shyam is a seasoned technology leader, a solution architect, and a data scientist. His extensive background equips him with unique insights into this evolving landscape of AI and its implications for the workforce and industry. So before I hand over the session to him, I'll quickly take you through the flow so that we can answer, as many questions as possible. We have kept all the attendees in listen only mode. You can send in your questions in the chat. And remember, what Shyam covers today is just the beginning. The field of AI and ML is vast and ever evolving, and there is so much more to learn and explore. So I invite you to consider enrolling in our AI ML course, where you can, deepen your understanding and also gain hands-on experience in these exciting areas. So yes, we encourage you to engage with us. Feel free to ask as many questions as possible and share your thoughts during the session. Without further ado, let's dive into what deep learning is. Over to you.
Hey Lakshana, thank you. Hello everyone. Welcome to today's session on deep learning unlocked, right? Here we will try to keep an engaging and practical and most importantly a forward-looking session, right? About deep learning. We will avoid some basic things like what is AI, right? I believe all of you are aware to some extent. So instead, we will anchor mostly around deep learning, the mechanics of it, right? What is the real world impact, and some case studies, right? So hope everyone is excited. So let's begin with what is deep learning, right? So folks, every major AI breakthrough, right, in the last decade, even self-driving cars, even ChatGPT, for instance, right, has deep learning at its core. It started with ImageNet way back in 2012, right? And then AlphaGo came out somewhere around 2016, which was able to beat the champion of the game Go, right? And then Transformers came in 2017, which was a major breakthrough, right? So it introduced what is called as attention mechanism, right? So it was a very important breakthrough architecture in the field of deep learning. And then came along GPT-4 and beyond, right? And all these are deep learning algorithms or architectures, right? And the message really is that deep learning is not a hype; it's the engine of modern AI, right? So we'll understand what is deep learning. So deep learning is obviously transforming the way machines learn, understand, and the it mimics the neural network of the human brain, right? What do I mean by that, right? So the idea was scientists looked at brain and they derived analogy from that, right? So brain has nearly 86 billion neurons. And what happens is each neuron takes input, which is like electrical signals. They process it and passes it forward. Artificial neural network mimic this at a simplified level, right? We can, of course, it cannot exactly mimic a brain, but it does it at a simplified level, right? So take an example. You're looking at a cat, right? What your brain does is it is not really running a checklist like it has 2 ears, it has whiskers, it has a tail, so it's a brain, right? So that checklist is not running on your brain, right? But instead, what really happens is millions of neurons fire in layers. Some of these layers, they detect the edges of the cat. Some of these neurons detect the shapes like a round eyes, triangle shaped nose, sharp whiskers, right? The shapes are detected. And some neurons detect the textures like fur, right? Fluffy, soft textures. And together they add up, they consolidate, right? All these neurons, they consolidate. And together it sends another added or cumulative signal to your brain that it is a cat, right? All these are happening in milliseconds or microseconds, right? So deep learning mimics this abstraction. What deep learning does is you have a picture of you have a picture, right? And let's say the picture is of a cat. So I'll make a very bad image of a cat, right? And then someone is looking at it, right? Or deep learning when it looks at this, right? So what deep learning has is layers, right? And within layers there are hidden neurons, right? There are multiple layers, right? So there you can choose the number of layers, and more the layers, it is deeper network, right? And lesser the layers, it's a shallow, uh, you know, shallow model, right? Or shallow algorithm. So it depends on the number of layers you choose. Each layer you can choose how many neurons it has, right? Very similar to brain, right? And when it looks at this, there will be some layers of neurons, right? Which is looking at the edges, right? Like for example, there is a sharp edge here, there's a sharp edge here, right? There's a curved edge here, right? And there's a sharp edge here. So there are neurons which are looking at edges. There are neurons which are looking at shapes, right? There are neurons which are joining edges and shapes, right? So multiple neurons are assigned multiple responsibilities, and together, right, they have a neuron which will be responsible for recognizing a cat, right? So that's the idea of um, deep learning, right? And in this visual here, you can see that the input is a car, right? You have feature extraction and classification that's happening, which is basically looking at the edges, the shapes, right? And then it is telling whether it's a car or it's not a car. Let's say it was able to find, and what you do is you have various images of cars fed into this network. Okay, so a car could be like a coupe car, right? It could be a sedan car. It could be a, SUV, right? It could be a MUV, right? And many sports car, right? So all these different type of car, you train the model, right? And again, the type of data you have depends on the quality of the data that you're training on, right? So the depending on the quality, and you tell whether this is a car or not, right? And you have other images which is not a car, right? Not a car like an aeroplane, or a human or a dog or a cat, right? Which is not a car basically, right? And you tell that this image is a car, this image is a car, this image is a car, this image is not a car. So over time, what happens is there will be neurons which will learn the edges of how typically a car edges are. There'll be neurons which will learn how typically the shape of a car is, right? There'll be neurons which will understand other features of a car, right? And together it knows how to classify a car or not car. Now, you are trying to classify an image now, a new image, right? It will now run these against these learned weights, what we call as weights, right? What are weights? They are the trained parameters, right, within the network. So it based on the weight, it will tell whether it's a car or not a car, right? So that's the intuition behind deep learning. Okay. Now, any questions on this, folks? Any questions on this? Right. Very brief introduction. So we'll get into some more details. Okay. So let's see before we come into the applications, right? Or let's look at different applications that use deep learning, right? For the next 10 minutes, look at different applications, right? So computer vision, right? Very, very, big, what you can say, use case when it comes to deep learning. So you might have seen radiology scans, right? And today, using radiology scans, we are able to detect tumors, right? So today, instead of a human doing that, we have models like convoluted neural networks, right? It is a deep learning model which is specialized in looking at doing visual, use cases, right? So they are able to detect tumors within radiology scans and be more accurate than what a human can do, right? And then there are assembly lines, right? In let's say manufacturing, right? Manufacturing, you have assembly lines. Let's say there was you want to do defect detection, right? And again, you need something that can do real-time inspection, right? A human can only do in batches, right? But you want to do real-time inspection for millions at scale, right? And that's where you can have again, a model such as CNN model, which can take images of the product within the assembly line and do, if at all there is any defect, that it can identify, right? So natural language processing, so basically it's being used in chatbots, in contract analysis, in fraud detections, right? And then you have GPT, right? So now it uses NLP plus the new architecture called transformers has kind of evolved the way we look at language. Now it's able to summarize GPTs, right, which is NLP plus transformer. It can summarize hundreds of documents in minutes, right? And what Chat GPT does, right? So it's so powerful. It can not just summarize, it can generate text, it can generate different ideas, right, as text. And then we have, recommendations where you have deep learning embedded within things like Netflix, right? So in Netflix, you have movie recommendation or show recommendations or documentary recommendations. How is it doing that, right? So there is a, recommendation engine, right? Which is powered by Netflix, right? And these recommendation engines are built on deep learning, right? And again, again, I can the recommendation engine itself is like a 2 week subject, right? So we cannot get into the technicalities, but what you need to understand is there are various techniques, like for example, user product recommendation, right? Or user recommendations, or product recommendations, or market basket analysis, right? So all these are different techniques, and based on that, there are nuances in the way you fine tune your deep learning model, right? So, and depending on that, you can use different types of recommendations, right? And then there is also, what is the business impact by Netflix using recommendation, right? If had Netflix not used recommendation engine, right, then how would the engagement be? How would anyone, get diversity of content, right? They would only go search for something that they want, and how do they get the stickiness to the platform? How do they convert from a wandering customer to a very engaged customer, right? So all these are benefits of recommendation engine, which is a straightforward benefit of using deep learning, right? And then there are autonomous vehicles, right? Self-driving cars, where we are fusing vision plus sensory details like lidar, right? So lidar plus vision is being combined, and we are able to have autonomous cars, right? Not only that, today drones, today robots, right? They are being used for logistics. They're used for agriculture, right? So we talked about Gen AI in the terms in the way GPT is being used for Gen AI for creations, for productivity, right? Copilot, right? So they are used for coding these days, right? Anybody can generate a piece of code, and they're used for designing, right? Designing templates, designing banners, right? And then they're used for marketing, right? So you might be in part of customer operations. Maybe you are a leader in a customer operations space, right? So today, large language models, which is again deep learning, right? What is a large language model? You have an NLP model, okay, which is trained on a data set, right? So mostly when you refer to language data set, we call it as corpus, okay? A small corpus, like for example, IMDb reviews, right? Or movie reviews or Zomato reviews, right? So all these becomes corpus. But if you take the whole of the World Wide Web corpus, right? If you take all the V books, if you take all the research books, everything combined, and you train a model, right, with that millions of corpus, that becomes a large language model. And the large here refers to the large millions of corpus that it has been pre-trained on, right? So it's another example of deep learning, right? Where you can use it to come up with bots or assistants, support assistants, right? And this way you can deflect 60% of the tickets, right? And you're in the customer operations space. Like for example, somebody has a issue with their product, and they're looking for an exchange, right? Or they're looking for a return. So a bot or an assistant can look at it and understand based on the information the customer has given, and initiate a, for example, a service, right? In exchange service, right? Just one moment. Yeah. Sorry about that. So we were talking about all these different applications, right? So I see the audience is very quiet. The 40 of us here. Any questions so far? It could be related to deep learning, or it could be related to how you have to approach your learning with respect to deep learning, or how you want to transition your career from whatever you are here to, let's say, data science, ML engineer or a data scientist, right? So anything around these, feel free to ask on the chat window, right? Yeah, Arushi, welcome to today's session. Hopefully, you know, uh, you're able to gain some knowledge, by this discussion. Please feel free to ask any questions that you may have, right? So we talked about customer operations, right? So today there are voice and multilingual support provided by these deep learning models, right? It can do a real-time translation from, let's say, Vietnamese to English, right? And it has a global coverage, minimal agent. You don't need not have different agents in different languages, right? One agent who can do the conversion and one probably a person who can look at English converted text, right? In sales and marketing, right? So you have proposals, you have RFPs, right? So you can have secure assistants which are trained on past proposals and different specifications, right? So now this assistant, what it can do is it can cut your cycle time by nearly 45%. Right. And we talked about recommendation systems. Deep learning models can personalize the content. You might have seen in Amazon. For you, you go search a product, it tells people who bought this also bought this, right? Or people who like this also purchase this. Or for you, depending on your history and your personalized interest, it will recommend products for you, right? So it will help you in engaging, it will help in conversions, right? Financial services, fraud detection using sequence models, fraud detection using, it's reducing false positives, right? So imagine 10 years ago, banks were very skeptical in giving away loans. Today, Bajaj Finance, they're sitting on the roadside giving away loans because they have models which will tell them how is the credit risk score of a person, right? How false positives look for this kind of person, right? KYC or AML, right? So today, all the KYC is done using deep learning, right? So Durg Vijay Maurya asks, he's a C sharp developer. How could I become AI developer? So you need not leave any of your existing programming language, right? Having to know a programming language is an advantage for you, right? So AIML can be learned even by people who are non-technical, who are in HR, who are in manufacturing, who are in oil and gas, right? But since you're already a developer, you know what a object-oriented programming is, you know what a functional programming is, you know how you can write routines, how you can access database, what is a, like for example, a client server architecture, what is a web client and things like that, right? So you already have those fundamentals which you can use to your advantage, right? And typically, in industry for deep learning for AI, we use Python as our go-to tool, right? So again, it's not set in stone. There are people who are writing it in Java, who are doing it in let's say Rust, right? And many other different tools. So you don't have to, but learning Python becomes very easy because you're a C sharp developer, right? That's my whole point. Even otherwise, Python is a very simple enough, self-explanatory declarative program, and you can quickly get up to speed on that, and you can use the libraries that Python supports to build algorithms very quickly, build models very quickly, fine-tune models very quickly, right? So again, it can be a fast track for you, Vijay. But if you're not a developer, if you're from, let's say, finance background, right? You can definitely learn Python, right? And again, there are various programs within Great Learning, like for example, a PGP in AML program, right? That has a boot camp for the first few weeks where you get into very foundational details like what is data, right? What are the different data types, right, that you will need? What is statistics, right? Many people won't even know the difference between median and mean, right? So all these are very foundational concepts that you come in with, right? And that's what this Basecamp prepares you for, right? And it also has Python, right, where it will teach you how you can do basic things using Python. And as you progress with learning, supervised learning, unsupervised learning, recommendation system, deep learning, right? So you will start, because everything you have to learn by doing it. You have to write code, you have to write Python that you have used. So progressively, you will be the place where you are able to like at least look at a code and understand what the model is doing, or be able to write a model on your own, right? So that's what Bhargavi, these programs help you with, right? Um, yes, Neha, good evening. And any questions you have, feel free to put that on the chat, right? So going back to our applications, there is this very new shift towards a risk and governance. We built so many AI models so fast that right now, people are thinking about risk. They're thinking about how we can govern these systems, right? Like for example, document extraction, right? For policy, now you extract, let's say, very sensitive information of customer. What is the model doing with that? Is it going to like put it back into training so somebody else can access it? Is it going to like for example store it into a database like which is publicly accessible, right? For classification, what kind of how is it doing the classification? How is it trained on? Is it biased, right? So LLMs, do summarizations, their tagging, their root documents, right? So all these are use cases that are being applied in risk and governance, right? So very, it's being applied all across, our life, and it's becoming very important, right? We talk about risk and governance, but needless to say, cyber security, right? So today, a lot of cyber attacks are happening, right? A lot of attacks such as injection attacks, right? Data injection attacks and cross-site scripting and all are happening. The people are trying to overwhelm the system, right? So there are firewalls built to do that, right? And this firewall is now embedded with deep learning algorithms. It can look at a request and say whether it's a legitimate source, whether it's a legitimate request or not. Otherwise, it will block right there, protecting your actual resource, right? So those are some of the examples and applications of deep learning. So how exactly deep learning works, right? So let's understand that, right? So deep learning, as I said, has something called neuron mechanics. Okay. So these neuron mechanics are, if you look at this architecture, right? So these are the hidden layers, right? So the what you see in the dots in a single vertical line are all hidden layers. I see one, two, three hidden layers, and there is a fourth output layer, right? So totally four hidden layers are there, or three hidden layers and an output layer, right? And or rather two hidden layers, one input layer and one output layer, right? So totally four layers. And each layer you decide how many neurons you need, right? Now the input layer neurons are fixed because you have four inputs, let's say, right? As represented in this example. And the output four layers are also fixed because you need four outcomes, right? Let's say this is to classify a cat, this is to classify a dog, this is to classify, let's say, a sheep, and this is to clarify whether, let's say, it's human. Okay. Now you can choose the number of hidden layers, right? These are what we call as hyperparameters, right? This is where you need to understand deep learning, technically, structurally, and systematically, right? So to be able to set those hyperparameters, right? And there is weights, like each of these neurons, right, have certain things called weights and biases. Each neuron has a weight and a bias, weight and a bias, weight and a bias, right? These neurons as well, right? These neurons also has weights and a bias, right? Weights and a bias, right? Now, whenever I input data, which is a raw data, comes through these hidden layers, there's a feature extraction happening. What do I mean by feature extraction, right? Feature extraction is during the training process, right? You can see these lines. Every neuron is connected to every other neuron in the following layer, right? This neuron is connected to this, this, and this. Likewise, this neuron is connected to this, and this, right? And likewise. So that's why these kind of networks are called fully connected neural networks, FNN. Okay. Now, in a fully connected neural networks, like I said, every neuron is connected to every other neuron in the following hidden layer, right? So this connection, what brings is what we call as weighted sum activation, right? So weighted sum activation, what I mean by that is during training, let's say I give raw data, right? And it go and I say, what is this raw data? Is this raw data a cat? Is this raw data a dog? Or is this a sheep or a human, right? Every raw data has a label, right? And now that's a very expensive process, labeling your training data, right? And that's why training a model becomes very difficult. So that's why we use a lot of times out of the box, we download open source deep learning models and use the pre-trained model, right? But here we are talking about training where you have labeled images, and each time the neuron processes those images, processes those input, right? It could be an image, it could also be voice, it could also be text, it could also be numerical data, right? Any kind of data, right? And it will go through these layers, and each layer will assign certain weights and certain bias, right? When it looks at the input data, for it to be able to classify that image, right, as that label. So each neuron has, an ad hoc weights and bias initially, and then it will set some loss function, right? And it will calculate the loss, right, at the end of the output layer. Now, if the loss is too high, what the model will does is it will try to retrace back, and it will try to adjust these weights and bias in a way that this loss function is negated, right? This process is called as back propagation, right? Now, again, I'm not going to too much details to it, can be too technical for some of you. So I'm getting very high level here, right? So image or any input data, every neuron has some ad hoc weights and bias. And the end of the network, a loss is calculated, right? Which is basically a mathematical function. And if the loss is too high, it will try to traverse back and adjust those weights. That next time when you pass that weight, the loss is very low, right? Like that, it keep adjusting for every single input data, right? You have millions of training data for the millions of times. It does a forward propagation and backward propagation, and it will try to adjust those weights and bias, right? Now the weights and biases are adjusted after running it through millions of training data, right? And these weights and bias are all numericals which you can go store it to a database, right? And these are called features. These are the features of the model, right? You can now just put it into a database, take this into a model, right? And start classification now, right? So now these features, it can help you do the prediction, right? Now, if there are too many hidden layers, then we call it deep learning because there are many layers. It can do hierarchical feature extraction, but there are just one or two layers like you see in this representation. It is called as shallow network, right? It's not a deep neural network, it's a shallow network, right? And it has limited capacity, right? And this loss function will tell you how wrong the prediction is. And back propagation will update the weights to minimize the error, right? If you have to give an example, it's like adjusting a guitar, right? Until it is tuned properly, you keep adjusting. Each pass, each time you try, you will try to fine tune the guitar, right? Same way, we are training on every single data many times, what we call as epoch, right? Epoch is one iteration in which the fine tuning happens, right? Wonderful. Right. So this is about deep learning. Again, it's a very complicated concept. I try to distill that and simplify that for you folks. But if you get into like PGP programs, you will be learning probably 3 or 4 weeks, right? Just deep learning, right? Sneha has a question. Pursuing BTech with E&C, want to learn deep learning, don't know the proper what to do, where I can start, right? Yeah, so basically, we will give, what is really the progression, right? If you want to get into deep learning, right? So the progression will be something like this, right? So you start with, Python because that is important, because any open source model that you pick up, you will need Python, right? And you need a little bit of statistics, right? You need a little bit of probabilities, right? So those are three foundational ones, right? Once you know this, you start progressing into supervised learning, right? What is supervised learning, right? Here is where you learn about regression or classification, right? So based on there are standard algorithms using which you can do regression or classification, or you can build your own algorithms, right? Mostly standard algorithms is enough to do most of the job, right? Now this is the part where we call as machine learning, right? Because you are using algorithms and training a model to be able to classify or predict a number, right? So once you're done with this, you move on to deep learning, right? To do deep learning, again, you need a little bit of polynomial algebra, right? You need a little bit of integral calculus, right? So I'm sure because you're an ENC student, you would have probably got exposed to some of these, right? But you need to apply these things, to understand deep learning, right? Now let's talk about why we don't use machine learning and why instead we use deep learning, or where exactly you would use deep learning and where exactly you would use machine learning, right? If that makes sense. So, uh, machine learning, folks, was heavily relying on feature engineering, right? How generally the data is tabular format, right? Like, for example, you want to predict whether it will rain or not, right? What kind of data you need? You need temperature, you need humidity, right? You need perspiration, right? Precipitation, sorry, right? Precipitation. You need wind speed, right? And whether or not it's cloudy forecast or what you can say, what is the um, is there cloud, right, or not, right? So based on this, you can predict whether it will rain or not, right? Now, all these data that you see, right, which derives whether or not it will rain is called independent attributes, and whether the result outcome is called dependent attributes, right? Now you need a lot of data like this, right, to be able to do machine learning, right? Because you're taking this data and applying that into statistical algorithms to see if there are patterns. Okay, whenever it is heavily windy and cloudy, it will rain. Whenever the temperature is low and humidity is high, it will rain. So the algorithm will look at hidden patterns like that and relationships within your data set, and it will try to learn based on that, learn based on your data set, right? And these machine algorithms can work very well with smaller data, maybe 100,000 rows like this. It can do simple tasks like predicting whether it will rain or not. It takes less time to train a model because 100,000 you can probably train in like 2 minutes. Models are built using relevant features which are extracted from images, because this is a structured data, what we call this as a structured data, right? But around our life we see a lot of unstructured data, folks. What are these unstructured data, right? Unstructured data is like, for example, if you take a backup of your WhatsApp, that's unstructured. There is no columnar structure. You will have to come up with structuring. If you take images, those are unstructured. If you take a book, ebook, that is unstructured data. right? Most of our real world problems are related to unstructured data, which machine learning cannot solve. You need to apply feature engineering and convert them to structured data and then apply them into machine learning. So that was the challenge with machine learning, right? It relied heavily on feature engineering. If I want to predict the house price, I can pick features like square footage, like zip code, number of bedrooms, right? Whereas in computer vision, I have to manually extract the edges, manually extract the texture, manually extract the colors, and then feed it to a machine learning algorithm, right? Like handcrafted features were not generalizing well with machine learning. You needed a domain expert who can do that extraction, right? So that's where deep learning provided us the breakthrough. It provided representational learning, right? These networks can automatically discover features. We don't have to provide them, right? These networks can find edges, shapes, and then objects without having to being told. Here in the deep learning, I didn't say, hey, this neuron, find me if there are whiskers. Hey, this neuron, find me if there are pointed ears. Right? I'm not telling that explicitly. It is auto assigning a set of neurons which will look at edge, auto assigning. So it's all very autonomous, right? The network will take care of it. I don't have to tell them that. Instead of telling the machine what to look for, we just give it data and it figures out the patterns. So this is why deep learning outperforms ML, especially when it comes to unstructured data like images, speech, and text. Bhargavi says, she knows statistics, probability, SQL, and right now learning Python. So are NumPy and Pandas enough? See, NumPy Pandas are one of the foundational libraries that we uh, uh, use in Python. Along with that, there are many other libraries, like for example, scikit-learn, which we use for using open source machine learning algorithms. There's something called matplotlib. There's something called plotly, right? So the matplotlib is used to describe data or visualize data, right? Very important for visualization, especially in EDA, right? We have a step in machine learning called exploratory data analysis, or it's an AI step, right? A very important step where we explore data, and that's where you need to visualize a lot of data, where you need to know matplotlib, right? Now, let's say you want to do certain mathematical operations to visualize data, you would use NumPy, right? Let's say for scikit-learn, it needs data set in data frames. To create data frames, you would use pandas, right? These are only foundational libraries, but there are many other libraries that we use, right? There are frameworks like TensorFlow. There are frameworks like Keras that we use in Python, right? So all these are very critical for you to do deep learning. Cool. Saravana says he knows only ML and did get a chance to learn with deep learning. So that's great. Definitely revisiting your machine learning, reinforcing the existing concepts of machine learning will help, right? And then getting on to deep learning with that foundation will set you up for great success when it comes to applying them in AI problems. So deep learning, like I said, definitely out perform machine learning, especially when it comes to unstructured data. How it is doing that using artificial neural networks, where it can understand hidden patterns and relationships. And you generally require a large volume of data compared to machine learning. Even otherwise, it's good, but your model may not have been fully trained on the weights and biases, right? It is always better suited for complex tasks, right? Like image processing, NLP. Deep learning takes more time to train because depending on the number of layers that you have, number of neurons, number of epochs, number of batch size, and the training compute that you're using, right? If you're training on a GPU, probably it will train faster. If you're training on a TPU, it might train much faster. But if you're training on your laptop, it might take more time. the relevant features that are extracted, right, are automatically done, right? And it's all part of an end-to-end learning process. I talked about forward propagation, backward propagation. Together, they become a end-to-end learning process. Deep learning is more complex, and it works like a black box, right? So once you model the architecture of your deep learning model, it can do it can do everything on its own. Everything is happening under the hood, right? So many a times you cannot do explain why your model is predicting or classifying a certain way, right? So it's like a black box. So wherever you need explainability, where you need interpretation, it might be complex, right? So there are again tools like Lime and many other tools which you can use for explainability, but still there are certain limitations, right? So that's the difference between machine learning and deep learning and why we use deep learning today, right? So here are some applications, more about where we apply them. Computer vision, for object detection, for recognizing an image, right? Image classification, we want to classify such as excuse me, animals, plants, buildings. Today, your mobile is able to unlock your phone with face detection. That is image classification, right? It's able to detect, someone's age, someone's smile, whether someone is smiling or not, right? Image classification. Image segmentation, much more complex thing to do, right? You need more sophisticated models to do that, right? It can divide the image into segments, right? And it can isolate those features, right? It's especially helpful in medical diagnostics and autonomous systems. It's used in NLP, right, to understand process, to understand and generate human language, right? For if you want automatic text generation, if you want language translation, sentiment analysis, speech recognition, right? So all these you can use NLP, right? And NLP has various techniques, right, to be able to do that. What are NLPs? Again, deep learning models, right? So these are again deep learning models, right? So what you do is you take a text, right? You want to do automatic text generation or you want to do sentiment analysis. So let's say somebody has posted a Facebook post, right? With a bunch of text, and you need to know whether that is a positive sentiment or a negative sentiment, right? So what you do, you take the text and you do something called vectorization, right? What is, or rather tokenization, right? So you tokenize the text into smaller subtext, right? And then you apply something called word embeddings, right? Where you're using machine learning algorithm to assign the semantics based on the semantics of tokens, assign them some scores, right? You do word embeddings. These word embeddings are fed into deep learning models, right? And here it will classify the sentiment as positive or negative, right? Great. So I see a couple of questions on Q&A. Folks, please use chat. Don't use the Q&A. I don't always look into that. Divya has a question, 11 plus years in IT and financial markets, C++, Java, right? What are the best career options for me to transition into AML-driven roles? Or business or strategy position? How do senior professionals like me best position themselves, stay relevant, and pivot to AI driven? See, great question, Divya, right? So, first of all, you have some programming knowledge, you have some domain knowledge in financial markets. So that positions you very well, right? And with a structured and the program like PGP, right? It will set you up to various career options, right? If you want to get into very technical aspects of AI, you can, start looking at data scientist role or applied AI engineer role or an ML engineer role, right? Or an NLP engineer role. Or if you want to get into product side of things where you are applying and you're conceptualizing AI into your products, financial market products, then you can look at product managers, product owners, right? You can look at team leaders, right? Our domain experts, right? Definitely that can set you up. But obviously, all these will require some structured learning, which is what programs like PGP provide you. You can also learn on your own, but you need too much of a commitment, right, and too much of a push, and you need that what you can say, a designed curriculum, right? Because today AI has become very broad and it's very the resource materials are infinite, right? So that makes it very complex to navigate, right? So hopefully that answer helps you, right? You're already coming with good experience. So with AI, you can definitely start looking at a lot of career options. But start small. Start with learning foundations like Python. Start with machine learning, right? See where you can apply your existing domain knowledge, existing IT skills into machine learning, and then progress to deep learning, and then maybe Gen AI, prompt engineering, and things like that. Okay, so it has to be progressive. Saravana Kumar says no, I know only ML, didn't get into. Yeah, so ML can perform by R or Python language. We have some stat libraries for deep learning. Which language? Again, we use mostly Python or R, right? So R mostly in the academic side of things, but in industry, most cases it is Python, right? If it might be Scala, Java in some edge cases, but and those are just outliers, right? So majority of the cases it is Python, and that's what you need to know. All right, we have about 5 minutes left, so I'll quickly try to talk about some architectures which are very important. Um, One of the architecture we talked about is CNN, right? So CNN is designed for images. It's an abbreviation for convolutional neural networks. And then we have RNN, which is recurrent neural networks. We have transformers, right? Which are basically, breakthrough we had in 2017, where you don't look at all words at once, not just sequentially, but basically to get the context. It will remember the context over time, right? And then you have many other architecture like GANs, and you have architecture like, for example, uh, what is RAG, right? Retrieval augmented generation. So Arushi says completely new to this field. It would see, to be honest, to set you up as a ML engineer, it might take few months, 3 to 4 months. But to become a data scientist who knows ML, deep learning, recommendation systems, Gen AI, prompt engineering, it might take an year or a little over an year, right? And again, it depends on your commitment, how much dedicated you are, trying out new examples, trying out, different models, training different data sets, right? You should be passionate about it and all that. So it depends on your commitment as well, but typically 3 to 4 months for ML, and maybe a little over a year for setting you up as a data scientist. So what are the advantages? It has high accuracy, and it is scalable, and it is continuously improving, right? So this is the institute we have been talking about, which will give you structured learning. It's great learning. It's the leading edtech company for professionals and your higher education. You don't have to stop doing your day-to-day job. You don't have to leave your workplace. You can do that along with that. It has best in class completion rates. I can vouch for it because I myself have been graduated from here. And there is a program that I've been talking about all along, which is a PGP in AIML, and it's a 12-month program. It has peer-to-peer learning. It has experiential hands-on learning, very critical. It's ranked number one for a long, long time. It gives you a dual certificate from Great Lakes and UT Austin. It is a flexible structure, right? So that makes it very, wonderful. Given all the other learning options you have, I think this is one that to vouch for. Here is the faculty. They are the best in business. They are the top notch when it comes to academic AIML. Dr. Kumar, Professor Gurumurthy. I have been, mentored by all of them. So I have had the privilege of learning from them. So they have coined this course, they have designed this curriculum. So you will be very safe hands, right? So this is the curriculum. A lot of you were asking, how do I transition, right? So there's the introduction to Python. You start with zero, right? You get introduction to Python, introduction to SQL, statistics, data processing, even if you have not done it. And if you have already know some of this, it can definitely reinforce your learning. And there are self-paced modules for Gen AI, recommendation system, object detection, right? And then you will be exposed to supervised and unsupervised learning, neural networks, deep learning, computer vision, NLP. You will be learning not just NumPy pandas. You will be learning 27 plus tools like Matplotlib, Keras, TensorFlow, and many more. There are immersive experiential learning that you can get by capstone projects. You can publish them onto your repository and use them to showcase your experience. There are hackathons, there are case study projects for every module. There's peer-to-peer learning, there's POCs that you will do. You will also learn what is AI, how do you coin business cases, right? And here are some real testimonials, people who have had career transitions, right? So if you are interested, please screenshot this, right? And Lakshana has put a link on chat. Please fill that form out. That will give us the feedback and also allow you to get back to you if there is any ask from you, right? Take a screenshot of this, bookmark the link on the Zoom chat, so you can take the next steps in your AML learning, right? From today's masterclass standpoint, we went into the deep learning, how it is critical for AI future, right? Hopefully you understood deep learning in a nutshell, and if you're interested in learning more, this is how you can go forward. Hopefully this was helpful, folks. Thank you for being a participative audience, and all the best. All right. Thank you. Bye.